Okay, this is question 4 on the non-graphing calculator part of the test. And again, we were supposed to get the domain. We're supposed to find the vertical asymptotes or pods, points of discontinuity. We're supposed to find the equation of the horizontal or slant asymptote, find the x and y intercepts, and then graph it. So I've got it set up there. And the first thing is, again, what sets the denominator equal to, we'll set the denominator equal to not 0 so we can get the domain. And the domain will be here x equals, does not equal -3, which means the same, do the exact same thing for vertical asymptotes, except you say they're equal to -3. So we'll go to graph that. That goes right there. Okay, so there's our vertical asymptote. I think that's pretty good. Okay, then we're supposed to check if there's horizontal or slant asymptotes. Now, in this particular problem, if you look at the degree of the numerator, here is, is 2, and the degree here is 1. So the top is higher than the bottom, so we have no horizontal, we only have slant asymptotes. And remember how to get slant asymptotes? You have to do long division, and if you can, do synthetic division. And we're set up for synthetic division very well. So I'm going to do that over in the bottom right quadrant. I'm going to do the synthetic division. So I'm doing x squared, which is 1, and there's 0 x's and 0 constants. And I'm going to synthetically divide it by, now it's x plus 3 on the bottom, so I'm going to use -3 there. And when I do that, I get a 1 here, then I get a -3, and that gives me -3 here. Now, I can continue on, but I don't really care what the remainder is. But I'll do that just for the sake of this. This is 9. This is 9. But remember, we don't care about the remainder when we're doing this. We care to interpret our, this was x squared, so this must be x, and this would be a constant. So this is our slant asymptote here. So I'm going to write that in here. The slant asymptote is y equals x minus 3. So we need to do that here. And how do we graph that? Well, we have to find -3, and then we have to, so there's our slant asymptote, and I can extend it if I want. Just go straight through here. And that would be the slant asymptote there, y equals x minus 3. Okay, so we've got those. Now we need to get the x-intercepts. Just as before, the x-intercepts is where y equals 0. When will this fraction be 0? When the top is equal to 0. So that's x equals 0, which means the coordinate is 0, 0. And the y, that also is a y-intercept because it's got a 0 for y. We're going to let x equal to 0, and if you wanted to really check it, you get 0 over 3, which is 0. And that's going to be right there. So we've got that as well, so we can graph that point. That's right here, 0, 0. Okay, now, how is this thing going? Well, what caused that? What caused it to get x equals 0 here was the top here. And again, if we look at this, it has a multiplicity of 2. That means it's going to be, this is going to be a tangent. That's tangent. So let's do some erasing here. Okay. Well, that's going to be a big mess if I try to erase it. So I'm just going to leave it. That's got to be tangent. So I know it's going to bounce off. Well, it's not going to go like this. There's no way for it to do this because we're actually have to cross the asymptotes and all that kind of thing. And you can't cross it. So I don't think it's going to do that. But if you want to double check, pick some points. So again, put -1 in there, let's say. -1 would become 1. Would become 1. If you negative 1 all squared is 1, and that would be over negative 1 plus 3 is 2. So 1/2. Negative 1, positive 1/2, that's right here. We got to bounce off that x-intercept, so we're going to have to come from above like this. It's going to follow that and not quite hit it. Okay, so that's there. If you want to see, there's going to be one down here as well. And if you're not sure why, well, this vertical asymptote came from the bottom here, which has a multiplicity of 1 implied by the way it's written. So that means that if this comes from the top, then this one must come from the bottom when you're on the other side of it. So that's why it looks like that. If you're on this side gets the top, then this side gets the bottom, and then you can't, so we know where it's coming from.